Good evening.
Well, good evening. Is it Sharon?
Yes, I'm Sharon Liz Herman from India, and it's great.
Awesome. And yeah, my name is Tori Smith. Hi. I am the co-founder of Endiatx. We make little robots that swim inside the human stomach, and hopefully we'll be able to go other places as well. But right now, PillBot is our primary focus.
Yes. So, as a grade 12 student, I would like to ask the first question that um, uh, many young people will be interested to know. Uh, where do you think the biggest opportunities lie in the next 10 years, especially in the field of endoscopy and medtech?
Well, opportunities in endoscopy specifically I think have to do with how we get the best care that patients receive traditionally in a hospital setting. Um, is there any way to take that care and dematerialize it in such a way that it might work outside of a hospital setting? And so uh, it's interesting when we look at human stomachs. Right now, we put endoscopes into maybe 1% of human stomachs in a given year.
Okay.
And so that means it's often involving sedation. A patient is, you know, physically going to a hospital. They're getting a tube inserted into their body. In the United States, that's a very expensive process.
Right.
It varies around the world. Um, where I'm from, here in San Francisco, you might have to go to a hospital several times before you get the actual endoscopy. And so it just means right now, if we want to look inside the stomach, say, it's expensive and it's difficult and it costs money. It incurs certain risks. And so we see a big opportunity when we think about the tip of that endoscope. Would it be possible with a little robot pill? Um, here's a current version of PillBot. This is
Okay.
pretty huge. Um, and then I can show you one I'm working on right now. Um, let me see here. A little bit
Right.
smaller.
Right.
Um,
Yeah.
right.
Significant. Yeah.
Yeah, we've obviously built many prototypes. Um, and the question is just if we can actually take the concept of a camera pill, which dates back to the late 1990s, and we can go one step further and have that thing move around. And we do need to give credit to the folks over at Onx Robotica with the NaviCam product. They're manipulating and maneuvering their capsule using magnetic fields.
Okay.
They're actually FDA cleared. It's an amazing product. And what it's allowing is it's allowing doctors and nurses to actively move this little eyeball around inside people's stomachs with no sedation, with no endoscope
Right.
thrust into their body. Now, they do require a piece of magnetic capital equipment to generate those magnetic fields and move that device around. And so, what we're trying to do on this long winded answer, what we're trying to do is get a moving eyeball into the human body that works anywhere, specifically that could work outside of a hospital setting. And so, the hope is that in a few years' time, someone could say, Alexa, my tummy hurts.
Okay.
And your home speaker would be able to say, how about a pillbot? And maybe a drone would drop it off, a few minutes later on your front door. And you could drink some water and swallow it. And probably at that point, we would want to be using AI tools
Right.
to, to not require a human to be operating every one of them. So I'm a few years ahead of of us right now.
Yes.
Um,
I
right
get
now,
it.
we just want to make it cheaper, easier, faster to look inside the human body. We think that a swimming robot in a stomach full of water may be an appropriate way to begin the adventure. And if we can secure the stomach as a beachhead for this concept of tiny little robots, swimming around in the body. But you can imagine we probably want to go beyond. I have a personal ambition. I think I have a prototype here. Um, One of my personal ambitions is to, eventually approach uh, rice grain size
Okay.
and be able to leave the GI tract. I've seen enough crazy movies and science fiction shows and read enough books um, to know that humans dream of nanobots in your
Yeah.
bloodstream.
Right.
And I'm not a, a scientist working on nanotechnology right now. I take a drone that you would fly at a park on a Saturday, and I try to squish that down into a package that you could swallow. I'm hoping we can go beyond that to rice grain size. Um, Probably need to look into some exotic forms of power to
Yeah.
power such a robot. Um,
Yes.
but I I think it's possible to do some really cool stuff. So we just need to start somewhere. To finish this insanely long answer to your question, I would like to take some of the most powerful medicine that you would see in a big hospital. I would like to dematerialize it into something that would work in your own home, but that offers the same power of diagnosis.
Yeah, the
And then
efficacy. Yes.
and Endiatx is a three-part name where we just squish some words together. Endo or END is the journey into the microcosmos of the human body.
Yeah.
Endo to go inside, or endoscopy to look inside.
Right.
Dia is like diagnostics, right? To understand what is wrong in the human body. And finally, TX and Endiatx is treatment. And the goal is that we're not just a little eyeball looking around forever. The goal is to have tools on these robots. And we won't be able to do everything with the first product,
Right.
and then just finish our R&D journey and just be done with it. No, we start simple and we build on it layer by layer. So maybe the first version of Pill Surgeon um, could have a little needle and maybe inject a simple drug, or maybe take a prick of tissue and run a very simple analysis on a small lab on chip inside the pill surgeon. Um, and then if that works, maybe we expand. But that's the dream of this company, and that's my personal dream.
Okay. That was a really long and elaborative answer. It almost answered most of the questions that I had in my list over here. So there was one thing I wanted to ask. Is is the PillBot able to make a 3D scan of the stomach yet, or is that going to be developed soon?
But you can imagine one of our hopes is that it's very obvious to sort of imagine what it ought to do, right? You
Right.
ought to be able to swallow this thing, let it drive around, collect a bunch of data, and let it create a three-dimensional model of your stomach. And that's interesting because your stomach is moving. Um,
Yeah.
and so that model would probably borrow some video game um, tech in the way that we handle deformable surfaces, right? But let's create an accurate scan of your stomach, um, and let's start to do recognition, right? If there's an obvious bleeding ulcer, I think it's plausible that an automatic diagnosis could come out of that. One of the other neat things is just sort of like for sci-fi and fun factor. Imagine you put on some extravagant AR glasses like the Meta Ray-Bans, say,
Yeah.
and
Right.
all of a sudden, boom, you see a living hologram inside the person's torso that's properly tagged and sort of location fixed, um, and you see like their glowing organ of the stomach, and you see the little pillbot swimming around and
Yeah.
scanning and getting more data. you see areas of lots of data and we've made conclusions, but you could also see shadow areas where it says, we haven't looked there yet. We need to go look there yet. And it really starts to look like a video game um, very quickly, right? And I just think it's a ton of fun. Um, and I think that if we kind of follow the ray of light of just the fun factor and the inspiration, I think it will take us to some really cool places.
Okay. Uh, so we were talking about fun and everything. So I just wanted to go a little informal and ask you, what was the most weirdest test or experiment that you did when you were developing the first prototype?
Well, I had to at some point make the transition from employee to founder. And, I call myself the co-founder of this company just to respect the other people who have helped me launch it. But,
Right.
you know, being honest, I've been dreaming about this my whole life. And I, I named this company, I sketched the logo for more than 10 years before,
Okay.
before I actually incorporated. So Endiatx is a very personal adventure to me. And so at some point, I had to stop being an employee of med device startups, and I had to somehow learn how to become a founder. And during that process, I went to a wonderful accelerator called Founder Institute that has chapters in India, I should say.
Okay.
I still mentor there. Um, and part of that process was stopping the sketching of PillBot and the sketching of the logo in the margins of my notebooks and actually getting serious. And so one of the first things that I did that was tangible um, for PillBot was, going onto my mill and, machining out of biocompatible plastic a representative capsule that was about the size that I thought PillBot would be, um, and swallowing it. And then, I want to avoid getting too gross, but
I get it.
going
Yeah.
and finding the thing the next day
Yeah.
and realizing like, wow, I just did a transit through the human body. Now can we make this thing real? That was pretty crazy. And then, the other thing was the first time we swallowed PillBot, um, June 17th of 2020. Um, we had incorporated the company in March of 2019. Um, and so, a few months after a year had passed, um, we were actually swallowing the first PillBot. And since then, it's just been a question of taking that technology stack and piece by piece trying to bring it up to a level where it would be clinically relevant. I
Okay.
should say right now that PillBot is not yet FDA cleared. I should say that we're under development and we're hoping to be in the market in maybe a year or two or three, something like that. Um,
Okay.
we now have a number of products that we're working on in parallel, and we should be, we're coming pretty close to doing our first big FDA filing. But even that, begins like 12, 18, 24-month type process. Um,
Right.
and the first product that we release will be simpler than PillBot itself, but it de-risks a lot of the tech stack and really kind of adds momentum. So I want to throw that out there to just say I truly believe that PillBot is going to be a big thing, and just hope people are willing to understand that launching a company and bringing it up to par with FDA scrutiny is not a trivial thing, and we are
Yeah.
really doing our best.
Yes, I get that. Um, there are a few more questions I would like to ask. Are the PillBot's parts, can we use old mobile phone parts for that? Like, it's just a,
We already do.
okay.
We already do. So let me see if I can find one of my circuits lying around here. Um, let me see. So yeah,
Camera,
like
especially, like,
I have bones of pillbots scattered all over my desk.
okay.
Okay, so this is one of our assemblies,
Yes.
and so you can see that we basically practice a little bit of electronic origami, so to
Okay.
speak. So, you fold up these islands and you get sort of a cylindrical stack of circuit boards. Um,
Okay.
we've become very friendly with the concept of a flex circuit. Um, but if you look at one of these pillbots, the camera that we started off using is actually the selfie cam from an old iPhone from a number of years ago.
Okay. Okay.
And so it's one of the old camera cubes, just a few millimeters square. Um, not the best uh, quality, not necessarily super tuned to work in the human body, but it worked well enough at the time. Um, the motors that we use to spin our propellers
Yeah.
um, actually come from old Nokia cell phones.
Okay.
Yeah, so nowadays, a modern haptic feedback device that buzzes your phone is usually not a rotating DC electric motor.
Okay.
It's usually a linear resonant actuator that basically shakes back and forth, but
Mm.
it doesn't involve rotation.
Right.
But the more traditional way that you would do rotation before they invented those or before those became mainstream was with a small electric motor
Okay.
with a little weight on the end of it that was
Right.
off center. And so when it rotates, it buzzes. And so we use cell phone buzzer motors in the device.
That's
And
great.
additionally, what else? Many of the chips that go onto the circuit board probably have found their way onto a number of consumer products. Cell phones would be one of those. So we really leverage a lot of what you see in the world of consumer electronics on the device. I will say though that we just had our first serious meeting to talk about an ASIC, which is application specific integrated circuit. An
Okay.
ASIC just means you're making your own computer chip.
Right.
And so rather than getting everyone else's computer chip and playing Tetris with it on a circuit board, if you have the capital and the time and you know what you want and you have the right people, you can burn your own computer chip. And that allows you to take a step smaller that is arguably on the order of magnitude. And that's a big deal. So when people look at a computer chip and you hold it in your hand, it's this brick, right? It's like a little rectangle. Um,
Right. Yes.
if you
A
flip it
very
over,
small motherboard, right? Yeah.
you might see like little dots on the backside of it where they solder it. Or it might have little metal tangs coming out that you place into holes on the circuit board. I used to think that's what the computer chip is it's that object, but typically that's not actually true. Inside that object is a much smaller piece of silicon um, that was actually coming out of the fab, maybe in Taiwan.
Okay.
And they make millions of those, and they cut them out of those big circular dies in the semiconductor process. And the actual computer chip is usually this tiny, tiny, tiny thing that's been placed in a large chip holder, um, and these tiny little wires connect it, and then they fill it with resin, so you don't even see that. And
Right.
where I'm going with this is that electronics have enormous price pressure to get cheaper and smaller, and electrical engineers usually are playing with the Legos that those chips are embedded into. And the
Okay.
form factor of those Legos um, might actually be much larger than you think. And so you might think you're playing with Lego, but really you're playing with Duplo. Um,
Okay.
and there's
Okay.
a tiny piece of silicon inside this.
Right.
And
Yeah.
yet you're packing this in, and you might pack this really tight with other pieces of Duplo, um, and you might think you're doing a really good job, but really, sorry, you're naive. You have no idea that it could be 10 times smaller,
Smaller.
right?
Yeah.
And so my hope is that for the engineers out there, for the people who are curious and passionate, don't don't take other people's assumptions and let those become your assumptions
Right.
of what's possible. You might have an instinct to pursue something, And it might appear that what you want to do is impossible, but it's possible that that could simply be a poor assumption, that it's very much a possibility if you're willing to do the hard work. And so in startup companies, you often have to question the basic underlying assumptions.
Yeah.
Um, and if you're willing to be very aggressive in the way that you question, um, what is normal, uh, you might be capable of starting the next great tech company.
Right. So it's not necessarily following the paradigm that is set, right?
Yeah, like, this is Silicon Valley. Move fast, break things.
Yeah.
Um,
Right.
doesn't doesn't necessarily mean be a bad person or
Exactly.
hurt
Yes.
other people or steal or lie or cheat. That is not what I'm recommending here. What I am recommending is that when you look in the mirror and you think you're not smart enough, um, give yourself credit that maybe you could become smarter, right?
Right.
If,
Yes.
if something is difficult and you feel like you can't learn it, well, maybe try harder for the next 18 months. Maybe on the 97th time you'll get it right.
Yes.
I I told my team that when we swallowed the robot for the first time, when we could get to that milestone, I said, we'll just go up to Sand Hill Road in Silicon Valley and we'll get millions of dollars in venture capital. And what I didn't realize is that the hit rate when you're fundraising can be 1%.
Yeah.
You might have 100 first meetings and countless follow-ups to get to a single check, right?
Right. Yes.
Um, and and that can be scary, and you might think it means it's impossible to get funded, but if maybe you just need to be there for the 101st meeting, right?
Right. Yeah.
For us, I think we've been rejected more than 1,000 times, but several dozen times people have said yes. um, and that's an important lesson for prospective founders out there is if you are truly in love with your vision, if you truly believe that the whole world is crazy because they're not doing this thing, you might just be a founder and you need to go create that company.
Right. That's so true. I loved your way of putting that through. Um, there there's one question I wanted to ask about the future models of PillBot. I should have asked this before, but yes. Um, is there any possibility of a shape-changing PillBot, not a
It's necessary.
rigid one? Yeah.
It's actually necessary, because, I mean, a drone that swims in the human stomach after you drink a ton of water probably makes sense that it looks like a pill, and squirting water is a good way to move around in that environment. But I mean, I lost my Aunt Katie to a glioblastoma brain tumor, and that was largely what kind of pushed me over the edge, leaving the world of aerospace engineering and entering the
I
world of
was about
medical,
to ask you that. Yeah.
right? Um, and so PillBot is my first step. It's not the last step, it's just the beginning. And so when I envision a brain surgeon version of this, first of all, it has to be smaller. I
Yes.
think rice grain size is appropriate. And we have friends in France, Robote, Bertrand Duplat, and Joanna Cartocci, who are now Series A funded. They are building rice grain size brain surgeon robots.
Okay.
Now, their robots do operate within a hospital environment. They're making some important um, design decisions that allow them to be functional, today. That my hope would be that when we get a chance to enter that arena, we are finding ways for these robots to move under their own power. I
Right.
really like being the telehealth telemedicine guy. It's sort of like my personal brand is I want this to work over a call just like the call we're on right now.
Right.
possibly not even need the call, but that concept of not being in a hospital is important to me. So how are we going to move around inside the brain? I mean, we have to be small, and then we're not going to swim, right? I mean, how would a horrible brain parasite move in your brain? It might look like a worm.
Yeah.
It might have little scary legs and a tail. It might have snippers in front. It might wiggle its way and worm its way around. Except this thing is not trying to harm you. It is going to kill a tumor. And so imagine a terrible brain tumor in the center of your brain. If we were going to cut down into that to go remove it with traditional methods, that would be very that would be non-trivial, shall we say? If we were going to hit it with radiation, um, that would involve a lot of radiation going to other parts of your brain.
Exactly.
Um, so, what if we had 6 to 12 tiny little robot surgeons parked there, right? They had gone in weeks before, very gently, maybe one following the next, so
Yes.
that these robots could potentially go all the way into the center of your brain and leave behind them a wound channel, damage, brain damage, right? Not good, but leave behind them a wound channel far smaller than a typical
Traditional method.
surgical
Yeah.
instrument would make. And possibly by going one after another, they would bring a capability that represented a large cross section in a tiny cross section. And then the next thing is, rather than doing a single surgery where we cut you open and we cut in and we remove this thing and then we put you back together, what if they could offer persistent surgical presence? What if these things were with you until the end of the resolution of this illness? So, what if you had tiny robots in your brain for 6 months or two
Right.
years? And what if most of the time they weren't actively cutting, they were simply listening, smelling, sniffing, recording, documenting, just bringing data into the ecosystem? Imagine if they were doing genetic analysis on the tumor tissue, um, so that scientists and doctors outside of your body could be formulating custom treatments
Right.
to unmask that, so that your own immune system, the tiniest robots of all, could go and do their work. And so we we do not presume that our robots will replace medicine that is out there.
Yes. Yeah.
We rather think that our robots may join the conversation, start carrying some weight, start opening up opportunities for doctors and patients, um, and start doing some good. I'm just hoping at some point, a gastroenterologist will call me up and say, Tori, I have PillBot and I've been using it on my patients, and it's easier to get a PillBot into my patients than an endoscope, and so
Right.
I'm scoping people that I wouldn't normally scope,
Yeah.
and I caught a early stage stomach cancer um, in a young, healthy patient who felt nothing, um, and their oncologist was able to cure it. And PillBot saved that life, and that might be a total fantasy because so many things have to go right for that to happen.
Yes.
But I love fantasies. Fantasies are where I get all my ideas, and I
Right.
simply pursue those dreams until some of them become real. Stomach cancer is a terrible diagnosis. Even early stage, it has really scary mortality rate. And so I don't want to make light of this. I simply want to let people know that um, there are people in the world who are actually quite ambitious and aggressive, trying to push the state of the art forward.
Right. Also, you had talked about bots going into the brain and everything. What about how safe is it to send bots to the heart, like for clots, for removing clots? You said about tools that could be attached to the PillBot, minuscule tools. So, yes, what's the possibility of that? And
So my
just warning you about the time limit, we have only 5 minutes left. So,
yeah,
yes.
I would say that I I have less experience in the cardiac area in blood
Okay.
vessels, but I do have a lot of experience inside arteries, in legs and arms. I spent 9 years at a company called Atheromed, where we designed a device called the Phoenix atherectomy system that went into arteries and mechanically cut and removed plaque.
Okay.
And so when an artery was blocked, we would go find that plaque, and remove it from the inside of the artery. And it's the obvious hope of that kind of technology to go into the heart and do coronary artery atherectomy, which is the removal of plaque. And so this is an area that I'm very passionate about. And so all I can say is when you're in an artery or in a vein and you're doing things, cutting, removing, um, it's very non-trivial. In the case of an artery in the coronary, um, you don't want to create a bunch of debris because that will go downstream and potentially start killing cardiac tissue,
Hmm.
because it would block small vessels. So you need to make sure that you're not throwing a bunch of clots. If we had a robot, say rice grain size, that could do brain surgery, we'd probably want to see if it could do some work in blood vessels, and we might change its shape and form factor a little bit so it could be more effective there. Um, but you'd be very concerned about clots, so you'd probably have the patient hopped up on major blood thinners while you're doing the actual procedure. Um, that brings in a risk of bleeding later, but it's always a
Yeah.
question of like all these different problems that you just slowly kind of address. Um, but the neat thing is, if we could do atherectomy inside a coronary artery using a small robot, probably make sure blood can flow past it. So
Hmm.
the cross section of that robot would probably be such that it's not blocking the whole lumen, and
Right.
so there's some kind of bypass, right? It's neat how if you just talk about the problems, the device starts to kind of design itself.
Yeah.
The neat thing is this patient um, might not need to be in a hospital. Um,
Right.
Maybe they could take a couple of blood thinner pills. Um, the neat thing is maybe you're not doing a massive procedure trying to remove a huge problem. Maybe you're doing a slow procedure over several weeks, and you could just gently, gently, gently be working on these areas. So
Hmm.
I think that the tiny robot presence in the body kind of buys you time and location and accessibility. It kind of changes the way we interact with the clock.
Right.
Um,
Yes.
Nothing trivial about this. I mean, I can get myself pretty scared thinking about all the ways it could go wrong, but
Yeah.
I also get pretty excited about the new possibilities that it could
Exactly.
put on the.
Yes. Yes. Okay. The last question. You talked about the PillBot, the first prototype that you experimented with, and how you swallowed it, and you tried to find it the next day, right? So, how does the PillBot exit your body? Is it like naturally, or is there any possibility of retrieving it? Maybe by bringing it back to the mouth or something like that.
We've done that. Yeah, my co-founder James can tell you a funny
Okay.
story about that. We try to keep the cost of the robot low in terms of physical cost.
Right.
Um, like I've been on stages and said numbers from $35 to probably $200
Yeah.
everywhere in between. As the
Yeah.
device has evolved and the quantity that you're looking at, there's always a unit cost um, associated with that. I mean, it might be $2,000 in a small batch, but
Yeah.
the hope is over time it becomes very, very cheap. We don't want to build retrieval into our primary product pathway because it's gross and icky, and it's not the kind of thing that someone who's in a lot of pain and is having a bad day necessarily needs added to their life. The,
Hmm.
the hope is you swallow the robot, the next day you go to the bathroom, you flush, It'll go down to the wastewater plant and get pulled out with a screen. They usually go to landfills, is typical. Right. So we do have pretty appropriate retrieval here in the United States. Um, in terms of not sending e-waste into the
Right.
ocean, for
Yes.
example.
Yes.
But the bottom line for us is just we want this to be like kind of like an Apple iProduct experience where, when you walk into the Apple store, you are experiencing consumer electronics at the highest tier.
Yes.
And there are many tiers below iPhone traditionally. But Steve Jobs said, that's fine, but we're going to be the best. We'll be the cleanest, the easiest to use, the best feeling in your hand. And other people are welcome to try to copy that. Um, that's what we're hoping to create with the PillBot experience from a patient perspective. Alexa, my tummy hurts. Here's PillBot. Swallow it. You have an ulcer. The medication will arrive in an hour from a drone. Now you feel better. You never went to a hospital, right? That if we
Yeah.
could make that a typical patient experience, that would be an amazing foundation to stand up upon. And from there, we can get into more complicated things like the pill surgeon or the microsurgeon. So we want to start off clean and fun and professional and futuristic. None of that involves a patient digging around in a toilet, in my opinion.
Right. Yes. Thank you so much for your time. I am afraid that's all the time we have left, but yes, thank you so much for sharing your inputs.